Okay, Algebra, this is a big week. We're studying quadratics the rest of the year, and I don't want to save up all of what we're doing in quadratics for one big test right before our semester final. So what we're going to do is we're going to stop this week, and we're going to test over stuff we've learned up till now. And next week we'll get into the quadratic formula, which is something new that we haven't got to yet. So what we're going to do today is a review over items we have learned that will be on the test, and then for our next class, Wednesday, Thursday, we're going to do a mid-unit test. All right, so that way we're breaking this up into two different sections. We'll do some testing now and then testing later over the second half. So it's not such a great big chunk to do all at one time. So we're going to go through problems together today. I'm going to set things up. I'm going to show you. You're going to answer. And then I'm going to show you what the correct answer was. So you won't be able to go back and redo this one many times because this is just a review. But you can go back and watch the video again, even if it doesn't let you change the answer you put in originally. So this will be a good review that you can go back and make sure you understand the type of things you're going to see on the test next class. So let's get right to it. All right. So starting out, how many solutions does each equation have? It's important to know that with quadratics, they can have 0 solutions, 1 solution, 2 solutions. We need to know which each one has so we know when we're solving it how many equations we're supposed to be coming up with. So x squared equals 144. So a solution would be x equals what? That would be a solution. If you tell me x equals 2, that is a solution, right? It's not a solution for this one. If we take x and multiply it by itself, x squared, what x multiplied by itself is going to give us 144? All right. 12 times 12 is 144. 12 times 12. Is there another answer? What would that be? There is another answer. What is the other answer? Negative 12. Remember, positive 12 and negative 12 both multiply together. So you can put on the test or something. There's that button that I taught you last time, plus or minus 12. This tells me there's 2 solutions. One's plus 12, one's minus 12. So this has 2 solutions. Okay, let's look at this next one. How many solutions does this have? How many things can we multiply by itself, x squared, by itself, and equal negative 5? Well, if it was the square root of 5, the square root of 5 times the square root of 5 is positive 5. If we have a number that's a positive, we multiply it by itself, it's going to be a positive. If we have a number that's a negative, and we multiply it by itself, a negative times a negative is a positive. There is not a number you can square and get a negative result. There are no solutions. This does not exist for us. We say there are no solutions there in Algebra 1. 4x equals 28. How many solutions they have? How many different x's would make that true? 1, right? If x equals 7, then 4 times 7 is 28. There's not another number you can multiply by 4 and get 28. How about this? X plus 6 times x minus 6 equals 0. How many different x's would make that a true statement? Hope you said 2, because if x was negative 6 plus 6 would be 0, and then we multiply it by whatever the other thing is. We don't care because 0 times anything is going to be true. It's equaling 0. Or if x was 6 and we subtract 6 from that, that's going to be 0. And so it doesn't matter what this is. If this is 0 and we're multiplying it, it's going to equal 0. So if it's negative 6 or 6, either way, that's going to be true. 2 solutions. Okay, the last one. 7 times x squared equals 0. What number could we put in there for x, multiply by 7, and equal 0? How many different numbers? Don't say 0. There is a number. There is 1 solution. Now, the solution is 0. So if you're saying 0, hope you're telling me that's the solution. 7 times 0 squared, 0 times 0 is 0. 7 times 0 is 0. There is not another number, but that is a solution. So Two solutions, no solutions, one solution, two solutions, one solution. All right, let's move on. Let's move on. This may take a little bit longer today, but you don't have another assignment to do. Video is your assignment. All right, let's look at what Jada was doing here. She was working on solving this quadratic equation. So she had this equation, x squared minus 5x equals 0. All right, didn't have that plus 9, plus 12. There's no constant after that, minus 16. Just has that. So she said, all right, here's what I'm going to do. I'm going to take that, and since there's an x in both the terms, and there's not a third term, I'm going to factor out an x. So this is the same as x times, parentheses, x minus 5. Because if I take x times x is x squared, x times minus 5 is minus 5x. This is the factored form of this standard form equation. X times x minus 5 equals 0. So, because of the zero product rule, right, that says if we're multiplying two things together to get a product, if this one's 0, it's going to be 0, or if this one's 0, it's going to be 0. So because of that, either the first factor, x, can equal 0, or the second factor, x minus 5, would equal 0. She says, so either x equals 0 or x minus 5 equals 0. So what would the first solution be for this equation? That was an easy one. It already says x equals 0. What would the second solution be? Well, there's only one number that we could subtract 5 from and get to 0. The second solution would be 5. So if x was 5, 5 minus 5 equals 0. That's it. Two solutions, 0 and 5 for that problem there. So it's good to look sometimes at what other people have done, because we can look at it and see things that they missed or didn't miss. Now, she did that right. She stopped before the equation. We did that. How many solutions? We're back to the how many solutions question. Make sure we're staying in focus here. All right. How many solutions for a quadratic equation? We were looking at that earlier with the equation. Now, if we graphed it, it should be even easier to tell us, right? Because a solution would be for a quadratic equation. She was looking for solutions. Jada was on this. When does this equal 0? When does the equation equal 0? Well, on a graph, when does it equal 0? We're talking about equations are usually a y equals type thing. Right? When is the y equal to 0? If we're solving an equation, when is it equal to 0? So this is when the y equals 0, right? When it's on the x-axis. Because when it goes up here, now it's positive numbers. Down here, the y is negative numbers. But when it's right here, it equals 0. So how many times does this equation equal 0? Twice, right here and right here. So this has two solutions. Wonderful. Excuse me. How about this? How many times does this equal 0? Never. This is the x-axis. It never crosses, touches, gets close to the x-axis. There are no solutions. How about this one right here? How many solutions does this have? Absolutely. One solution. It touches the x-axis and bounces off of it, basically. It doesn't cross it. It just touches it, and where it touches it right there is the point where that is a solution. So, looks like this has two solutions. If it doesn't touch, no solutions. If it just touches it and bounces off, could be coming from the bottom, bounce and go back down. Either way, it only touches one time. Just one solution. Okay, something else we'll need to be able to do. Rewrite quadratic equations. So these expressions are in standard form, and we need to rewrite them in factored form. Okay? So I'm going to get us started off here. The first term in here is x squared. So we know our two factors are both going to start with just an x, because an x times x is x squared. So that first term there. And remember, the last term would be the other terms of the binomial multiplied together. And then when we combine those, we'll get that middle term. So this last term has to be numbers that multiply together to be 12, or negative 12 in this case. Which, you've got 1 and 12, you've got 2 and 6, you've got 3 and 4, and that's about it. And unless you get into some decimals, and we're not going to get with decimals. We're just talking about whole numbers, because to factor it, we should be able to get whole numbers if it's factorable. So, which two numbers will we use? So, it's a negative, so no, one of these numbers has to be a negative, one of them has to be a positive. And when we use both of them, we've got to end up with a plus 1, plus 1x, right? That plus x means it's plus 1x. So it should be 1 apart. So using these numbers and knowing that one has to be positive, one has to be negative, what is the factored form of this equation? Let's see. If there's just one difference, this is 11 between the two of them. This is 4. This is only 1 apart. So if I want it to be positive, I'm going to make the bigger one positive, make the smaller one negative. So I'll make an x minus 3, x plus 4. You could have put those x plus 4, x minus 3. That's the same answer, right? Doesn't matter if I go 2 times 4 or 4 times 2. It's 8 either way. So you can switch those, but that is the factors of this. All right. Now we have to rewrite this one in factored form. This is a little different. We don't have an x squared. We have a 9x squared. Now, generally, we look at it, and if this looks to be a perfect square, we want to break it out as a perfect square. What multiplies times itself to get 9x squared? I'm going to get you started on that. The factors of this one have to start with 3x. All right? 3x times 3x is 9x squared. So generally, it looks like this may be a perfect square trinomial. If so, then this will be a perfect square. And then when you multiply those together and double it, you'll get that middle one. So what would be the factors of this one? Figure that out. Let's look. 16. That would be, I'm going to try, since it is a perfect square, I'm going to try first the perfect square. And if that doesn't work, then I'm going to have to get creative and look at the other options. But since this is a perfect square, 3x times 3x, 4 times 4 is 16. So that makes 16 is a perfect square. So if I put, these are all positives, so plus 4, do I end up with 24x as the middle term? Because these terms are correct. This will give that, but it has to give this too. So 3x times 4 is 12x. And 4 times 3x is 12x. And when I add those together, I get positive 24x. This is the correct factored form. It was a perfect square trinomial. If you know it's a perfect square trinomial, then all you have to do is look at these numbers and put it together. Should work great, right? This one we weren't sure if it was, so we had to double check to make sure that those middle terms lined up. And it should, if it is a perfect square trinomial. All right, so rewriting, you need to be able to do that. If not, get with Miss Smith or I, either one of us. We are available to help you understand this before you have to take the test later this week. All right, select all the expressions that could be equivalent. Oh, I know there's one like this on the test. I've looked at that, and I said, that's a pretty good question. X squared plus bx, which means they're not telling us the middle term, minus 18. Okay, so some of these, now please people, if it says select all, how many times was there just one answer when it says that? Very, very, very rarely is there only one answer. If it says select all, I would choose at least 2 answers because it didn't say select the expression. That would be one answer, select all. And I still see people do that. Every assignment that has that, you'll choose one answer. All right, so probably at least 2 of these, maybe more, would both be a factored form of this equation because b could be a different number. It's a variable. But we want to know where b is negative. So could be a different middle term, but we want the ones that are negative. Okay, x squared, we know it's going to start with an x and an x, right? Because that's the only thing that can be x squared. Negative 18, and it's a positive right there. So negative 18, it's got to be a positive and a negative because that's the only way we can multiply 2 numbers together to get a negative answer. So one of these terms has got to be positive, one of them has to be negative. And 18, 1 and 18, 2 and 9, 3 and 6, and that's about it. That's our only options. So any of these can multiply together. So let's check to see if we can rule any of these out because they don't have the right numbers. That's what I do first. X and x. X and Okay, they all start with x and x. Do they all start with a pair of numbers? Do they all end with a pair of numbers that could be negative 18? 3 and negative 6. Yeah, that works. Negative 2 and 9. Yeah, that works. 6 and negative 3. Yeah. Positive 2, negative 9. Yeah. Negative 1, positive 8. Okay, all of those could work. So you have to figure out, if I do those, if I multiply the first and last term and this, which one is the middle term going to be negative with? Okay, select all the expressions that tell me which ones. Is it A and B? Is it B and C and D? Is it A, B, and E? Which ones would make the B negative? All right, let's look. This will be a plus 3x and a minus 6x. So if I put those together, that equals minus 3x. This one would make the middle term B a negative. It'd make it a negative 3. Now, I'm doing this shortcut. I showed before when we first started dealing with, if we had two factors like this, x minus 1, x plus 18. Remember, we tried to figure out how to put it in standard form. We put the box. We had x times x was x squared, negative 18. We're not worried about those last two numbers because we know they're the same in all of these. We've already checked that. We're looking at these two. Negative 1 times x is negative x. 18 times x is plus 18x. And then when we wrote it all out, we wrote all of those terms. Now, again, I'm only looking at the middle ones, the negative x and the plus 18x. That's why that's all I did there, was just the middle terms. I'm not worried about the x squared and the negative 18 because they're all x squared and negative 18. So this one would be a negative 1 and a positive 18. That's a positive 17x. So that was this one. It could not be. How about this one? Negative 2 and a positive 9. So it'd be 9x and negative 2x. That would be a positive. That'd be plus 7. Plus 6x minus 3x. It's kind of the opposite of this, the minus and the positive. That'd be a plus 3x. Can't be that one. Minus 9x, positive 2x. That would be a minus 7x when those are together. So those two would make the middle term a negative number. The other three would all make the middle term a positive number. And so they would all work with different values. And this is negative 7x is the middle term. Negative 3x is the middle term. Those would have a positive, different numbers as the middle term. But that's how you need to check that, is just the middle terms. The 2x and the negative 9x makes that negative. So whichever one's bigger, right? The negative was bigger. The positive was bigger. And that kind of helps you figure out, is the middle term going to be negative or positive? All right. One or two more problems here. Just right here, last page. Solve each equation for x. Absolutely. We got to know how to solve for x. When it says solve this equation, that means what does x equal? Show your work. Okay, there is a button. I think it says like change the background or something like that. You click on that and it will open up the screen where you can show your work. You can write out what you're doing, or it has a button over you can play with the different buttons. One of them is a type. You click it and then you can type out what you're doing. You may have to click it again and do another line. Okay, so you can either type it or you can use their little pen and write on the screen. But show your work. We've got to solve this. Now this first one, we like it. It's already in factored form, right? We were looking at that problem that Jada did. Where's Jada's problem? Jada did this problem where she got it to factored form and then just set both the factors equal to 0 because the equation was equal to 0. Well, let's look at ours. Ours is in factored form and it's equal to 0. Great. So either this first factor, x minus 2, should be 0, or if 3x plus 9 equals 0. If either of those factors are 0, that's a true statement. So what x would make this true? Add 2, x equals 2. There's one of our solutions, 2. What would make this equal to 0? All right, subtract 9, 3x equals negative 9. Divide by 3. X equals negative 3. It's got to do the work. All right. So you will see that when you take the test, it will say show your work. You'll have that box change background to do that. This video, very limiting. Doesn't have as many options. So show your work on the test. Okay, this one's not equal to 0, first off. So even if we put this in factored form, it doesn't equal 0. But the first thing I notice is this is -2. So the only thing that can multiply to be -2 is -2 and 1. I mean, -1 and 2 or -2 and 1. And neither one of those are going to add up to -8. That means we're going to need to complete the square. You had to have seen that coming. We went over completing the square. It's got to be on our test somewhere, right? All right, so completing the square. Let's move this to the other side because that -2 does not work. So we got x squared minus 8x plus something is going to make that a perfect square. And the other side is 9 plus something. Remember, if we're going to add it to the left, we're going to add it to the right. So we have to find out which number, this is just a coefficient of 1, so we don't have to worry about multiplying by whatever's in the front. We need the number that when we cut that in half and multiply it by itself would be that number. So what number do we need to put there? Well, if we take -8 and cut it in half, it's -4, -4. So -4 times -4 is a positive 16. Positive 16. That makes that a perfect square. Wonderful. So let's break this down into its factors now. So this has to be, we said -4 is what works. X minus 4, x minus 4. That is the factored version of the perfect square trinomial that we just created. And the other side is 9 plus 16. That's 25. It's 25. Okay, let's rewrite this. This is the same as x minus 4 squared, because x minus 4 times x minus 4 is x minus 4 squared. And 25 is the same as what squared? Well, it could be 5 or -5. So I'm going to leave that as 25 at the moment because we're about to say, here's our two factors, x minus 4 and x minus 4, and they could equal 25, but there's two numbers we just said, right? 25 could be 5, could be -5. So I didn't want to write that as 5 squared because that's only one thing it could be. It could be -5 squared. So since we know this could be either one of these, this is the same factor twice. So that's going to be the same thing. X minus 4 has to equal 5, right? Because if we take that and we square it, it's going to equal 25. Or x minus 4 equals the other option could end up as -5, right? So if x minus 4 equals 5, what does x equal? Plus 4 plus 4, x equals 9. Hope you got 9. What if x minus 4 equals -5? What does x equal? Plus 4 plus 4, x equals -5 plus 4 is -1. All right, we found the solutions by completing the square. X equals 9, x equals -1. If we take either one of those and substitute that in there, 9 times 9 is 81, minus 8 times 9 is 72. So 81 minus 72 is 9. Minus 2 more equals 7. 9's a solution. -1 also works. -1 squared is a positive 1. -8 times -1 is a positive 8. So positive 1 plus 8 is 9. 1 plus 8 is 9. Minus 2 is 7. So these are both solutions, which we got by completing the square. So that's all the problem review we're doing. The test should be those type of problems. If you understand those, you're doing well. If not, come see us. We are online. We want to help you be able to understand. The test will be on Wednesday, Thursday, whichever day you have class. Get online, and it will be on GoFarmative to where you can enter those answers. I don't know. You can watch this video as many times as you want. You can go back and watch previous videos if you like. Okay, I'm not understanding from this video. Where did we do that? Go back and find the lesson where we were completing the square or anything along those lines that you didn't get on there. But most important thing is come see us if you're confused about something. I'd rather talk it over with you, show you some more examples. I can put this screen up while we're online and we can work things out on paper like this. Works wonderfully. Even if you don't want to put your video up. Some of you guys like to do schoolwork in your pajamas. It's all right. I'm with it. A lot of jammies around here. A lot of times all day. I've got 5 people in the house with my daughter, and then my son-in-law and daughter are living with us. So I understand that. All right. Study well. Do work you can be proud of. We'll see you next time.